Find the HCF of 12, 18 by Euclid's division lemma, or simply EDL. So the first thing what we need to do is doing the normal division of the given two numbers. 12 ones are 12, 18 minus 12, 6. Now this one we need to write in the form of A equals to BQ plus R, nothing but dividend equals to divisor into quotient plus remainder. Dividend 18 equals to divisor into quotient 12 into 1 plus remainder. Now from this step we need to pick the divisor and the remainder. We need to do division for these two numbers, 6 and 12. 6 2s are 12. 12 minus 12, 0. Again for this one we need to write dividend equals to divisor into quotient plus remainder. So dividend equals to divisor into quotient plus remainder. Whenever if we get the remainder as a 0, we need to stop the process there. So after getting the remainder as 0, we need to check the divisor. So that is 6. Then HCF of 12 and 18 is 6. Next, find the LCM as well as HCF of the numbers 72 and 108 by prime factorization method. So first let us do the prime factorization of the number 72. 72 will come in 2 table. So 2 36 are, 36 will come in 2 table, 2 18s are, 2 9s are, then 3 3s are. So 72 is equals to 2 into 2 into 2 into 3 into 3. The same way let us do prime factorization for the number 108. 108 will come in 2 table. So 2 54s are, 2 27s are, 3 9s are, 3 3s are. So 108 equals to 2 into 2 into 3 into 3 into 3. 2 into 2 into 3 into 3 into 3. So now prime factorization completed. From this prime factorization we need to write the HCF as well as LCM. So first let us go with the HCF. From these two, whatever the numbers are common, those all we need to write in HCF. Here 2 is there, so 2 into, one more 2 is also common, so 2 into 3 is common, 3 into, one more 3 is common, 3. So 2 2s are 4, 4 3s are 12, 12 3s are 36. So HCF of 72 and 108 is 36. Then what about the LCM? First write all the common numbers. What are the common numbers we have here? 2 into 2 into 3 into 3. What exactly we wrote in HCF? Into, now whatever the extra numbers we remained with, those all numbers we need to include in this LCM now. Here number 2 is extra, so into 2 into, here number 3 is extra, write that 3 also now. So we will become 2 2s are 4, 4 3s are 12, 12 3s are 36, 36 2s are 72, 72 times 3. 216. So LCM of the number 72 and 108 is 216. Next, check whether 8 by 125 is terminating decimal or non-terminating repeating type of decimal. If it is terminating decimal, then find the decimal of that number. So 8 divided by 125, which is equals to 8 by 125 can be written as 5 power 3. 5 into 5 into 5. So already we know if the denominator is in the form of 2 power n into 5 power m. I repeat, if the denominator is in the form of 2 power n into 5 power m, then we can say that it has a terminating decimal. So here the denominator is 5 power 3. So for that base is 5. So the denominator is in the form of 2 power n into 5 power 3. Sorry, 2 power n into 5 power m. Then it has terminating decimal. Then if it is terminating decimal, we need to find the decimal of this, right? So let us check how to find out the decimal. So the given question is 8 by 5 power 3. Here 5 power 3 is there, so we need to multiply and divide with 2 power 3. We remains with 8 into 2 power 3. 2 into 2 into 2. Again it is also 8 by 5 cube into 2 cube. 5 2s are 10. 10 cube. 8 8s are 64 divided by 10 cube. 1000. 64 divided by 1000. 0.064. Next. Prove that 6 plus root 2 is an irrational number. On the contrary, let us assume six plus root 2 is a rational number. So 6 plus root 2 can be written in the form of P by Q. But our textbook is following A by B. So that is the reason we are also writing A by B only. So on the contrary, let us assume 6 plus root 2 is a rational number. Then 6 plus root 2 is equals to A by B. What is the condition here then? A comma B both belongs to integers. B not equals to 0. A comma B are co-primes. Okay, now 6 we will take to the right side. Then we remains with root 2 equals to A by B plus 6. If we are taking another side, becomes minus 6. This 6 I am writing it as 6 by 1. So root 2 equals to, here both the denominators are different, so I am going with the cross multiplication process. B into 1 B, A into 1 A, minus 6 into B, 6B. Okay, now according to the condition, A comma B both are integers, right? So here in the place of A and B, whatever the integer you substitute, always this right side part we will get a rational number only. Whereas this left side root 2 is an irrational number. So that we need to write it here as A comma B are integers. RHS is rational, but LHS is irrational. This contradiction has arisen due to our wrong assumption. Next, write 2 log 3 plus 3 log 5 minus 5 log 2 as a single logarithm. So we have one formula, log A power m equals to m into log A. For the main number, if power is there, means that power will come to the front as it is. So it becomes m log A. The same formula, if I read it in reverse, m log A equals to log A power m. It means in front of the logarithm, if any number is there, means it will go as the power for the main number. So now by using this formula only, we are going to solve this question now. Okay, observe the question clearly. 2 log 3. In front of the logarithm, 2 number is there, right? That 2 will go as the power. Plus 3 log 5. Here 3 is in front of the log, that will go as the power. Minus 5 log 2. This 5 is before the log, that will go as the power again. So let us write this. Log 3 power 2 plus log 5 power 3 minus log 2 power 5. Log 3 square 9 plus log 5 cube 125 minus log 2 power 5. In logarithms we have some formulas. So one of the formulas is, if plus is there in the logarithm, we need to make it multiplication. That formula is log A plus log B equals to log AB. So log 9 plus log 125 will become log 9 into 125 minus log 2 power 5 as it is I am writing. Sorry, otherwise 2 power 5 number we can write directly. What is 2 power 5? 2 into 2 into 2 into 2 into 2, 5 times. So 32 that is. So now we remains with log 9 into 125. 9 5 is 45, 5 4 carry. 9 2 is 18, 22, 2 2 carry. 9 1 is 11. 1125 minus log 32 as it is. Now based on this also we have one more formula, that is log A minus log B equals to log A by B. If minus is there means simply we need to write it in the division form. So log 1125 minus log 32 will become log 1125 divided by 32. If x square plus x square plus y square equals to 6xy, then prove that 2 log of x plus y equals to 3 log 2 plus log x plus log y. So in this question or in this kind of questions, the first thing we need to observe is whether it has any positive symbols or else any negative symbols. If you observe this question, in this total we have plus symbols only. So if the question consists of all the plus symbols, then we need to add 2xy. In case if at least one negative symbol is there, then we need to subtract 2xy. For what then? From this equation. From that equation we need to add 2xy, otherwise we need to subtract 2xy. That will be based on this second equation. If the second equation consists of all positive numbers, then add 2xy. If it contains at least one negative symbol, then subtract 2xy. So in this case all are positive numbers, so we need to add 2xy. Okay, let us take the given equation. X square plus y square equals to 6xy. Adding 2xy on both the sides. So what it will become? X square plus y square plus 2xy equals to 6xy plus 2xy. Now left side part if we observe clearly, x square plus y square plus 2xy, it is in the form of a square plus b square plus 2ab, that is equals to a plus b whole square. So x square plus y square plus 2xy is equals to x plus y whole square, which is equals to 6xy plus 2xy, that is 8xy. Now in the question we have logarithm also, but here we didn't get any logarithm at all, so apply log on both the sides. Log of x plus y whole square equals to log 8xy. In the logarithm, if the power is there for the main number, it will come to the front as it is. So log of x plus y whole square can be written as 2 log of x plus y, which is equals to log 8 into x into y. In logarithm, if multiplication is there means it will become addition. So log 8 plus log x plus log y. This left side part I am writing as it is. 2 log of x plus y equals to log 8 can be written as 2 power 3 plus log x plus log y. Again writing the left side part as it is. 2 log of x plus y equals to, this power 3 will come to the front as it is. 3 log 2 plus log x plus log y, hence proved. Next, find the number of digits in 4 power 2013 if log 2 equals to 0.3010. So the given number is 4 power 2013. In this, the base is 4, but the given value is for log 2. 4 and 2, if they have any connection, means we need to use that connection. So 4 can be written as 2 square power 2013 as it is. that is equals to 2 power. If 2 powers are there with the help of bracket means we will multiply those 2 powers. That is the formula a power m whole power n equals to a power mn. So 2 into 2013, 4026. Now for this one, keep log. So log 2 power 4026. Here if the power is for the main number, it will go to the front as it is. So then we get 4026 log 2, which is equals to 4026 into log 2. Value is given in the question as 0.3010. 4026 into 0.3010. So if you multiply these two, let us check what we'll get. 4026 into 0.3010. 1211.826. After multiplication, we will get some kind of decimal like this. Now, before the decimal, which number will be there? That is 1211. For that number, we need to add 1. So it becomes 1212. For every time compulsory, if you are doing this question means definitely you need to add 1 for the number which is before the decimal. So 1212. So totally 1212 digits will be there. Next. Set A equals to x such that x equals to 2n minus 1, n belongs to capital N, that is natural numbers, n less than 4. Write in roster form. So they gave the set builder form. That set builder form we need to convert to roster form. X equals to 2n minus 1. This is the equation which they gave, and he's saying that n belongs to natural numbers. So natural numbers will start from 1, right? So n equals to 1, 2, 3. Now next, what exactly he gave the condition? N is less than 4. So it means 1, 2, 3 only. So the numbers are 1, 2, 3. One by one number we need to substitute in the place of n. If n equals to 1. So x equals to 2 into, in the place of n, substituting 1, minus 1. 2 ones are 2, minus 1. 2 minus 1, 1. Next, if n equals to 2. In the place of n, we need to substitute 2. So x equals to 2 into 2 minus 1. 2 2s are 4, minus 1. 4 minus 1, it is 3. Next, if n equals to 3, then x equals to 2 into 3 minus 1. 2 3s are 6, minus 1, it is 5. So the elements in that set are 1, 3 and 5. So set A equals to 1, 3, 5. This is the roster form, writing all the elements in the set. Next, write 5, 25, 125, 625 in set builder form. So now the question is already in the form of a roster form, that is all the elements are given. Now by using those elements we need to write, or we need to create the set builder form. So what is exactly the set builder form? Set builder form is nothing but writing some hidden pattern or hidden logic what is there in the question. So let us check then how to write. Always the set builder form opens with the bracket like this only, with like a normal one. X such that x is equal to, this is common. Now observe the elements which are given in the set clearly and try to find out some pattern or some hidden logic in that one. So let us check once. First number is 5, second number is 25, then third number is 125, then last number is 625. 5 can be written as 5 power 1, 25 can be written as 5 power 2, 125 can be written as 5 power 3, 625 can be written as 5 power 4. So these are powers of 5. So in all these, base is 5 common, right? So write 5 again. Next, if you observe the powers 1, 2, 3, 4, they are starting from 1. So that I am taking as with small n, where that n belongs to, we are writing from 5 power 1, right? So starting from 1, this is natural number system. Till where we are writing then? 5 power 2, 5 power 3, 5 power 4 only. So n less than 5, because till 4 only we are writing. If set A equals to 1, 2, 3, 4, 5 and set B equals to 2, 4, 6, 8, then find A minus B with the help of a Venn diagram. So draw a rectangular box which comes for universal set, that is represented with mu. And in the question, two sets are there. One is set A and one is set B. So draw two circles. One circle for set A and the second circle for set B. Before drawing this kind of Venn diagrams, you need to make sure one thing very clear, that is any common elements are there in the given two sets or not. So here common element is there, so that is the reason we are touching these two circles with each other. In case if those two sets doesn't have any common element, then we need to draw those two sets as separate like this. So that is the reason, keep every time whether any common element is there or not there. Okay, now what is that common element? Oh sorry, one more element also there, 2. That's it. So 2 and 4, both 2 are common elements, right? This 2 and 4, we need to write it in the part where common area is there. So this is the common area for these two circles. So write there 2, 4. Now coming to the set A. In the set A, still 1, 3, 5 is remaining. Write those 1, 3, 5 here. Next, in the set B, 6, 8 are remaining. Write those 6, 8 here. Now in the question, he is asking to do A minus B. So this part is A minus B. That's it. This is A minus B through Venn diagram. Next question. Find the value of x cube minus 2x square plus 5x if x equals to minus 1. So simply in the polynomial, wherever we have x, in the place of x we need to substitute minus 1. So the polynomial x cube, in the place of x substituting minus 1 whole cube minus 2 into x square minus 1 square plus 5x 5 into minus 1. So what is minus 1 whole cube? That is minus 1 into minus 1 into minus 1 minus 2 into minus 1 whole square minus 1 into minus 1 plus 5 into minus 1. Minus into minus plus, plus into minus, minus 1 into 1 into 1 into 1 into 1. If 1000 crore times if you multiply also, 1 into 1 only, minus 2 into minus plus 1 ones are 1 plus 5 into minus 1. So here minus 1 as it is, minus into plus, minus 2 ones are 2, plus into minus, minus 5 ones are 5. If all the terms are negatives, we need to do addition but keeping the negative symbol. 5 plus 2, 7, 7 plus 1, 8, adding, then keep negative symbol. So answer is minus 8. Find zeros of 2x square plus x minus 6. I am going to find the zeros of this quadratic polynomial by the method called splitting the middle term into two terms, or else simply factorization. Constant is 6. X square coefficient is 2. So 6 2s are 12. 12 will come in which tables? 1 12s are, 2 6s are, and 3 4s are. 4 3s are, 6 2s are, 12 1s are. So only these three pairs are possible in this. Now checking for the symbol. Here the last term is negative and the middle term is positive. If the last term is negative and the middle term is positive, in every pair bigger number should be positive and the smaller number should be negative. So 1 is smaller number, negative. 12 is bigger number, positive. 2 is smaller number, negative. 6 is bigger number, positive. 3 is smaller number, negative. 4 is bigger number, positive. Minus 1 plus 12, 11. Minus 2 plus 6, 4. Minus 3 plus 4, 1. Here the middle number is x, right? So x is nothing but 1x. So x coefficient is 1. Then this last pair is the correct pair. So write the first term as it is 2x square. That plus x can be replaced with minus 3x plus 4x. Last term minus 6 as it is. Now from the first and the second terms we can take out x common. Then if we take out x common, then we remains with 2x minus 3. Now from the third and fourth term also we need to take something common. After taking common, here what we got inside of the bracket, the same we need to get here also. Now observe the third term. Third term is 4x, but here already 2x completed, then remaining is plus 2. So plus 2 we need to take common. Now 2x minus 3, 2x minus 3, it is there 2 times, right? So write it once, 2x minus 3 times x plus 2. These are factors of the given polynomial. Then we need to find out the zeros, right? So here minus 3 is there, so plus 3. Here multiplied by 2 is there, divided by 2. 3 by 2 is one of the zeros. Next, here plus 2 is there, then minus 2 will be the second zero. So 3 by 2 and minus 2 are zeros of the given quadratic polynomial. Find zeros of x square minus 5x minus 24 and verify the relation between zeros and coefficients. So first, for the given polynomial, let us find out the zeros. X square minus 5x minus 24. Multiplying the constant and x square coefficient. Here constant is 24 and x square coefficient is 1. So 24 ones are 24. 24 will come in which tables? We need to write all those. 1 24s are, 2 12s are, 3 8s are, 4 6s are. In reverse again, 6 4s are, 8 3s are, 12 2s are, 24 1s are. Now if we observe the given polynomial, middle term and last term both are negatives. If the middle term and last term both are negative, so in the given pairs, bigger number should be negative, smaller number should be positive. 124, 24 is bigger, so negative. 2 and 12, 12 is bigger, so 12 should be negative and the next number should be positive. 3 and 8, 8 should be negative and 3 should be positive. 4 and 6, 6 should be negative, 4 should be positive. Okay, now if you observe this, plus 1 minus 24 minus 23, plus 2 minus 12 minus 10, plus 3 minus 8, it is minus 5, plus 4 minus 6, it is minus 2. So this middle number is minus 5, so this pair is satisfying that. So first term x square as it is, minus 5x can be replaced with plus 3x minus 8x minus 24 as it is. Now from the first and second term we can take out x common, then remains with x plus 3. From third and fourth term also we need to take out something common. After taking that common, we need to remain exactly x plus 3 only inside of the bracket. So observe the third term, that is minus 8x. Here minus 8 will be remained because x already completed inside of the bracket. Now x plus 3 it is there 2 times, right? So write it 1 time x plus 3 into remaining is x minus 8. So x minus 8. Then what will be our x values or zeros? So x plus 3 is there, so x value will become minus 3. X minus 8 is there, our x value will become plus 8. So minus 3 and plus 8 are zeros of the given quadratic polynomial. So in this, take minus 3 as alpha. So alpha equals to minus 3 and 8 as beta. So beta equals to 8. Alpha is minus 3 and beta equals to 8. Alpha and beta are nothing but zeros of a quadratic polynomial. So we need to find out sum of the zeros as well as product of the zeros. Sum of the zeros, alpha plus beta equals to alpha is minus 3 plus beta 8. Minus 3 plus 8, 5. Next, product of the zeros, alpha into beta. Alpha is minus 3 into beta 8. Minus 3 into 8 minus 24. Now sum and product of the zeros we need to find out, but with the help of formulas. So alpha plus beta formula is minus b by a. Alpha into beta formula is c by a. So let us check what these values we will get then. So the given polynomial I am writing x square minus 5x minus 24. Here I am writing to separate again. X square minus 5x minus 24. Before x square nothing is there, so it means 1. X square coefficient is a, x coefficient is b, and constant is c. So a value is 1, b value is minus 5, c value is minus 24. So here minus b value is minus 5 divided by a value is 1. Then c value minus 24 by a value 1. Minus of minus 5 plus 5, this is minus 24. Now we need to compare these answers with the previous answers. Alpha plus beta 5, here also 5. Alpha into beta minus 24, here also minus 24. So verification completed. It means this is without formula and this is with formula. Without formula also, with formula also, in both the cases you got the same answer. Next, if 1 and minus 3 are zeros of a quadratic polynomial, then find that polynomial. So whenever if we have zeros, to find the quadratic polynomial, we have a formula k into x square minus alpha plus beta into x plus alpha beta. So k into x square as it is minus alpha is given as 1 minus beta is given as minus 3 into x plus alpha is 1 into beta minus 3. Let us simplify this now. K into x square minus 1 minus 3 minus 2 into x plus 1 into minus 3 minus 3. So k into x square minus into minus plus 2x plus into minus minus 3. So in this case we don't have any denominator, right? So if denominator is not there, then take the k value as 1. So if k equals to 1, then the required polynomial is x square plus 2x minus 3. Next, we have a triangle ABC and he's asking check whether DE is parallel to BC. So he's asking us to confirm this DE line as well as BC line, whether are they both equal or not equal. So to check that one, what exactly we need to do is upper one by lower one you take, that is AD divided by DB. So AD value is 3 by DB is 4.5. 3 ones are 3, 1.5s are, so 1 by 1.5. The same way take the right side also, upper one by lower one, that is AE by EC. AE by EC. AE how much? 2 by EC is 4. So 2 ones are 2 twos are, it is 1 by 2. Here if you observe, this is 1 by 1.5 and this is 1 by 2. Both are not equal. So AD by DB is not equals to AE by EC. If these two ratios are not equal, then these DE and BC line are not parallel. So DE is not parallel to BC. If those ratios are same, then only those two lines are equal to each other. Next, in this triangle ABC, if DE is parallel to BC, in this question only is clearly mentioning that these two lines are parallel to each other. Then he is asking to find out some missing number. So if these two lines are parallel to each other, then we can say that upper one by lower one, that is AD by DB, AD by DB equals to upper one by lower one, that is AE by EC. So what are the measurements we got? AD is 2 by DB is 4.4 equals to AE 3 by EC X. some unknown number we need to find out. So first let me check any cancellation. 2 ones are 2, 2.2. So we remains with 1 by 2.2 equals to 3 by x. Let us do cross multiplication. 1 into x equals to 3 into 2.2, 6.6. So x value is 6.6. Next. Oh, we have one tangent sequence related question. Okay. This OA will become radius, AP will become tangent. Where the radius is touching the tangent, always it makes 90 degrees. So this is 90 degrees. Opposite to the 90 degrees, it is always hypotenuse. So this will become hypotenuse. Right angle triangle is there, means obviously we will go with the Pythagoras theorem. So let us apply Pythagoras theorem here. Hypotenuse square is equals to first side square plus second side square. 5 square 25 equals to 3 square 9 plus x square. Take 9 to this side, then we will get 25 minus 9 equals to x square. 25 minus 9, 16 equals to x square. X square is 16, then what will be the x value? It is 4 units. Next, if edge of a cube is 2 centimeters, then find total surface area of a cube. What is the formula for total surface area of a cube? 6a square. So 6 into a square. A is nothing but edge of the cube, that is given as 2 centimeters. So 2 square. So 6 into 2 square, 2 2s are 4. 6 4s are 24. We are finding that area and the measurements are given in centimeters. Then TSL will become centimeter square. So total surface area of the cube is 24 centimeter square. Next, if curved surface area of a cylinder is 132 centimeters square, whose radius is 3 centimeters, then find height. CSA of a cylinder. CSA of a cylinder is 2 pi RH. This is given as 132. So let us substitute the numbers. 2 into pi value 22 by 7 into radius is given as 3 centimeter into height is unknown number, which is equals to 132. Now we need to find out the height, right? Remaining all we will take to right side. So then h is equals to 132 into 2. If we take another side, it becomes 1 by 2. 22 by 7, if we take another side, it becomes 7 by 22. And 3, if we take another side, it becomes 1 by 3. So let us do cancellations. 11 2s are 22. 11 1s are 11 2s are. 2 1s are 2 6s are. 2 1s are 2 3s are. Here 3 will get cancelled. Then height is equals to, in all these only number 7 is remaining. So height is equals to 7. In the question all the measurements are in centimeters. So this is equals to 7 centimeters. Next, if sine theta equals to 4 by 5, then find the value of secant square theta minus tan square theta. Sine theta is given as 4 by 5. So draw right angle triangle. This I am taking as theta. So if that is theta, then this will become opposite side and this becomes adjacent side. This will be hypotenuse. Sine theta is 4 by 5. Sine is nothing but opposite by hypotenuse. So this is 4 and this is 5. Now by using the Pythagoras theorem, we need to find out the third side. So hypotenuse square equals to first side square plus second side square. 5 square 25 equals to 4 square 16 plus x square. Take 16 to the left side. So 25 minus 16 equals to x square. So x square equals to 25 minus 16, 9. Then x square is 9. Then what will be the x value? It is 3 units. So adjacent side is 3 units. Then he is asking to find the value of secant square theta minus tan square theta, or sec square theta minus tan square theta. What is secant? hypotenuse by adjacent. Here hypotenuse is 5 and adjacent is 3. So 5 by 3. Square is there, so whole square, minus tan theta. Tan is nothing but opposite by adjacent, so opposite is 4, adjacent is 3. 4 by 3. Again square as usual, whole square. This square is applicable for numerator as well as denominator. So 5 square 25 by 3 square 9. This square is applicable for numerator and denominator. 4 square 4 4 is 16 by 3 square 3 3 is 9. Here both the denominators are same. So write the denominator one time and subtract the numerators. 25 minus 16, it is 9. 9 9 both will get cancelled. Then finally we remains with answer 1. So the value of secant square theta minus tan square theta equals to 1.